This is lesson 7.3 and 4, and this is about right angle triangle trigonometry. In this lesson, what we're going to do is we're going to kind of break it into 3 parts. In the first part, we'll talk about right angle triangle trigonometry. In the second video, we'll solve for sides, and then the third video, we'll solve for angles. To start, all of the triangles in this first part of the unit are going to be right angle triangles, and these trigonometry skills only work in right angle triangles. So let's dive into right angle triangles. There's 3 sides to any triangle, but when it's specific to a right angle triangle, they have specific names. For example, one you've probably already heard is hypotenuse. Hypotenuse is the side that's across from the right angle. And because it's across from the right angle being the biggest angle in a right angle triangle, that means that the hypotenuse will also always be the longest side. The adjacent side is the side next to, because adjacent means next to, a given angle. So when you talk about an angle that's not the right angle, the other side that's touching that angle will be the adjacent side. Opposite side is the side across from a given angle. So let's look at a triangle. We've got triangle XYZ, and we're going to identify the hypotenuse, adjacent, and opposite side for each of the indicated angles. In the first example, we're talking about angle X, and in the second example, we're going to talk about angle Z. They're the same triangle, but when we label hypotenuse, adjacent, and opposite, it changes depending on what angle we're referencing or what angle we're talking about. If we're talking about angle X, the side opposite angle X would be the side that's not touching the angle X. So we have this side and this side touching X. This side's across from angle X, not touching the angle. So this is our opposite side. So I'm going to put an O with a box. Opposite we label with an O. I'm going to put a box around it so it doesn't look like a 0. That's our opposite side. There's another label we could give this side, and that's side X. When you label sides, they get the same letter as the angle it's across from. So this is side X. The hypotenuse will be the longest side, and the longest side's always the one across from the right angle. The right angle's here. The side across from it would be this side. This side is side Y. This is our hypotenuse. And that leaves one side to be our adjacent side A. Side Z, or Z. That would be our adjacent side. Now, adjacent means next to. It's next to a given angle. And if we look, we have angle X, the angle we're talking about. There's 2 sides that are next to it. One's the hypotenuse, so that can't be the adjacent, which makes this side the adjacent. You can always tell the adjacent as well, because the adjacent will always be the side that's touching both the 90 and the angle we're talking about. So we have the angle we're talking about X, we have the 90, this side's touching both, that's our adjacent. All right, let's talk about our second triangle. It's the exact same triangle. We have side X, side Y, and side Z. But what changes is where the H, A, and O go, the hypotenuse, adjacent, and opposite. They change because now if we talk about angle Z, we have a little bit of a change. What's the change? Well, the side across from angle Z would be side Z, so that would be our opposite side. The side across from the right angle would be our hypotenuse. And the side that's left over, touching the 90 and the angle we're talking about, is the adjacent side. And if you look, H stayed the same. The hypotenuse didn't change. It was always the one across from the 90. What did change is O and A. Opposite is always across from your angle of reference. Angle of reference, opposite. Angle of reference, opposite. The leftover side is the adjacent side. So depending on what angle you're referring to, the way you label the triangle changes. The opposite and adjacent sides of a triangle will switch depending on the reference angle. Okay, and that's our first step to right angle triangle trigonometry, being able to properly label all three sides of the triangle with an H, an A, and an O, hypotenuse, adjacent, or opposite. Why do we do that? Well, if we want to find sides and angles in right angle triangles, we need to learn three special ratios. And those special ratios are the sine ratio, the cosine ratio, and the tangent ratio. The sine ratio will compare two sides of a right angle triangle. The sides they compare are the opposite and the hypotenuse. And the cosine ratio will compare the adjacent side and the hypotenuse. And finally, the tangent side will compare the opposite and the adjacent. What do I mean by compare? Well, what I mean is that if you have an angle and you press sine of that angle, now sine being a button on your calculator, SIN, all calculators will have this, all scientific calculators, sine, cos, and tan, sine, cosine, and tangent. We can call them sine, cos, tan, or sine, cosine, tangent. These are three special buttons that help you solve for sides and angles in triangles, and what they are is they relate to a ratio. If you know an angle and you do sine of that angle, what you're going to get is whatever the opposite length is divided by the hypotenuse length. And I'm going to show you what this looks like in a second. For the cosine button, if you do cosine of an angle, you're going to get the adjacent length divided by the hypotenuse. And if you do the tan of an angle, you're going to get the opposite length divided by the adjacent length. So let me show you how this works. Here we have a triangle with 3, 4, and 5 and an angle 53 degrees. We can press sine of 53 and we're going to get an answer. We can press cos of 53 and we're going to get an answer. We can press tan of 53 and we're going to get an answer. Those answers are going to relate to these three ratios. Now, these three ratios can sometimes be tricky to remember, so what we've done is we've come up with an acronym for remembering which button goes with which two sides. And that acronym is SOHCAHTOA. Where does that come from? Well, here's where it comes from. The sine ratio, S, compares the opposite and the hypotenuse, SOH. The cosine ratio compares the adjacent and the hypotenuse, CAH. And the tangent ratio compares the opposite and the adjacent, TOA. That's where SOHCAHTOA comes from. So if you can remember SOHCAHTOA, SOHCAHTOA, you can remember the three primary trig ratios. So let's look back at this triangle. Let's type in sine 53, cos 53, and tan 53 into our calculator to show you what we get. Sine 53 gives us 0.7986. Let's round it to 0.8. Let's do cos 53. Cos 53 gives us 0.601. Let's call that 0.6. And tan 53 gives us 1.327. Let's call that 1.33. Now remember, sorry, I'm going to write down here, we used a calculator to figure this out. Calculator. Now let's try using the ratio. Well, the sine ratio is opposite over hypotenuse. So if we're looking at this triangle, let's label it. O is across from the angle we're talking about. We're talking about 53. H is across from the 90. And adjacent, A, is between the 90 and the angle we're talking about. So now we have H, A, and O labeled. The sine ratio is opposite divided by hypotenuse. Opposite side is 4, hypotenuse side is 5. We have 4 over 5. If we do 4 divided by 5 in a calculator, we get 0.8. Notice that sine 53 gives us the same thing as the opposite over the hypotenuse, the 4 over 5, 0.8. These answers match up, 0.8 and 0.8. So what this means is we have two things that we can say are equal. We can say sine 53 equals 4 over 5, or sine of an angle equals opposite over hypotenuse, which is our first primary trig ratio. And the power of this is now we have a relationship between two sides and an angle in a right angle triangle. So if we had these two sides, we could solve for the angle. Or if we had an angle on a side, we could solve for another side, and that's where we're going in the next two parts of the lesson. Let's finish. Cos 53, well, cosine ratio is adjacent over hypotenuse. The adjacent side is 3, the hypotenuse side is 5. We get 3 over 5, which is 0.6. So again, we have 0.6, 0.6. I think you might see where this is going. Tan is opposite over adjacent. The opposite side is 4, the adjacent side is 3, so we have 4 over 3, and if you divide those, you get 1.33, actually 1.3 repeating, but we're rounding, so there we have 1.33, 1.33. Now you might ask, we had to round these to make them equal these, and the reason we did is because this angle right here is not truly 53 degrees. It's actually a little bit smaller, a little bit bigger than 53. We've just rounded this angle to demonstrate that they're equal. If you actually had this 3, 4, 5 triangle, this angle would not be 53 degrees. It would be like 52.8 or 52.9 or 53.1. It'll be something a little bit more precise. It'll give you the exact ratio. But that's beside the point. The point is that we now have 3 very powerful equations that we're going to use in future lessons. So what do you need to be able to do? Well, you need to be able to use your calculator to type in sine of an angle and get answers. We already did these 3, 0.8, 0.6, and 1.33. What I'm going to ask you to do is to try sine 37, cos 37, and tan 37 and see what you get. Note, this angle is 37 degrees. You might notice something about the answers you get here compared to the answers you get here. And if you don't, that's okay. I think throughout the course of the unit, you may come to notice this. And if you really want to know, and you can't figure it out, ask me. Okay, that's part 1 of 7.3 and 4. Please watch part 2, which will be using SOHCAHTOA to solve for sides. Thanks for watching, and I'll see you next time.